So no one's actually asked for this, but recently I watched a video on Standupmaths about 3 dice. Now, the problem is basically if you have 3 dice and you roll it, is there any way you can set up an algorithm or something like that so that it gives a result as if you roll 2 dice? Now, I had to go at it, and there's loads of paperwork and stuff like that on it, but I'll try to briefly explain my results and an algorithm I came up with, which is not perfect, but let's see. So I'll first of all, I'll leave a link in the description to the actual link of the video that he had the problem on, that Matt Parker had the problem on, and so you can watch what the actual problem is. So basically, we need to make 3 dice mimic or give a result as if we're rolling 2 dice. Now, I wasn't sure whether we wanted all the results, 2 to 12, which are the results possible on a 2 dice. I wasn't sure whether we wanted those results in equal probabilities or in probabilities as if you would get on 2 dice. So 7 being the highest and then 2 and 12 being the lowest. I wasn't sure. So I kind of worked, trying to get an algorithm for both of them. And yeah, it kind of didn't go out that well. The first way that I came up with was basically trying to find some way where you can use the sums of the 3 dice and categorize it down into the 11 possibilities of the 2 dice. But that failed miserably, and I'll tell you why. So if you roll 3 dice, the possible sums that you can get will be between 3 to 18. 3 being if you rolled 3 ones, and then 18 obviously being if you rolled 3 sixes. And so what I did was I went onto Excel, listed out all the permutations, all the 216 permutations I can get on 3 dice, and then summed it and then find how many times those sum will occur out of the 216 possibilities. And I get a table that looks a bit like this. So as you can see, the total that is most likely to occur will be 10 and 11. With 27 times out of 216. So I also worked out the probability of each result if you roll 2 dice. That's the classic problem. And the probability, instead of putting it over 36, I'll put it over 216. So that it's easier to compare this result of the 2 dice with the result of the 3 dice. And so now the answer seems quite easy to get, because all you just have to do is you just have to find which combinations of the results from the 3 dice will be equivalent to the probability on the 2 dice. You just have to say, right, if you get this result or this result on the 3 dice, this will be the same as this value on the 2 dice. And if we can do that, then we just basically solve the problem. But there is a reason that this cannot be done. Well, you see, to roll a 5 or a 16 on 3 dice will have equal probability as you rolling a 2 or a 12 with 2 dice. So you can just say that if you roll a 5 with 3 dice, that will be the same as 2 points. And if you rolled 16 on 3 dice, that will be the same as getting a 12 on 2 dice. That's 2 of them crossed out. But the reason that it was crossed out so easily was because the probability was exactly the same. They were both 6 out of 216. But the rest of the numbers, they don't match up. Now in the table for when you're rolling 2 dice, apart from the results of 2 and 12, the rest of them has probabilities that does not match with any of them on the 3 dice result, on the total of the 3 dice. So that means if you want to get the same probability as if you were to roll 2 dice, you'll have to say 2 of the results on the 3 when you're rolling 3 dice will equal to a certain result when you're rolling 2 dice. So I could say something like, if you were to roll an 8 and a 4, the probability would be 3 out of 216 plus 21 out of 216, which would be 24 out of 216. That's the same as if you were to roll a 5 with 2 dice. So we can say if you either roll an 8 or a 4 with 3 dice, that'll be equivalent to getting a 5. But there's a problem, because with 3 dice, you can get 16 results. But with 2 dice, you will get only 11 results. And say there's already 2 that we already was able to match, and we'll say there's going to be 14 results left on the 3 dice that we need to match with 9 results on the 2 dice situation. But there's a problem because we cannot give a pair of the results of the 3 dice probability to each of the remaining 2 dice probability. We would need at least 18 results remaining so that we can say 2 of these results gives the same probability as a certain one of the 2 dice. But we don't have enough. We don't have 18, we only have 14 left. And so we cannot possibly rearrange it so that, say, a certain number or numbers, if you get it on 3 dice, will equal to a certain number on 2 dice, so that the probability of rolling 2 dice is preserved. That's not possible. And even if we say that the probability of getting 2 to 12, we will say it's the same, it's all going to be 1 over 11. If you multiply that into the 216 possible permutations of rolling a 3 dice, you'll get a bunch of decimals, and you can't have a decimal of a permutation, so there's no way you're going to rearrange it and have the numbers fit nicely. So the sum method is out of the room. So we'll have to go to another method. Instead, we'll have to consider the combinations of the 3 dice. Now the first question is, how many combinations are there even? Now combinations is not the same as permutations, obviously, because in combinations the order of the dice does not matter. To work out the combination of the dice, you have to consider that in the 3 dice you can either get all the 3 dice being the same, there's going to be 6 possibilities for that, or 2 of them is going to make a pair with each other, and then the other one's just going to be another number. So that 1 dice can be any number, so there's 6 possibilities. And then those 2 will have 5 more possibilities of being any pair it wants. So if the first dice is a 1, then the pair could be a 2 pair, or 3 pair, 4 pair, 5 pair, 6 pair. So the combination of getting a single and a pair would be 5 times 6, which is 30. Now the probability of all 3 dice being different will be 6 times 5 times 4, because the first dice can be any, then the fifth, then the next one will be 5, there's only 5 left, the next one will be 4, but because it's combinations, orders doesn't matter, so we'll have to divide it by 3 factorial, which is how many ways you can rearrange those 3 different dice, and that comes down to 20. So you add all of those up and you get the combination of 3 dice to equal to 56. 6 ways to get all 3 dice the same, 30 ways to get 2 pairs and a different die, and then 20 of getting all different dice. And here, in case you don't believe me that there's 56 combinations, I'm going to list them all on the screen right now. And what's the probability of each of these combination of dice coming up? Well, to get all 3 dice the same, it will obviously be 1 over 216 each. The probability will be 1 over 216. So the probability of getting 3 dice the same, whatever number, will be 6 over 216. Now what about to get a pair and a single? Well, the probability of getting one of them, let's say 112, if you draw a tree diagram of how to get to 112, it will look a bit like this. As you can see, there are 3 ways you can get to a combination of 112. So the probability of getting to one of those combinations will be 3 out of 216, because the method of getting to that any combination with a pair will be the same. The probability of getting to any pair, will equal to 90 out of 216. Now what's the probability of getting any combination of 3 dice that's all not the same? Or if you draw a tree diagram of each possibility of getting, say, 1, 2, 3, it'll look like this. As you can see, there's 6 ways you can get to that combination. So the probability of that combination, of rolling that combination, will be 6 out of 216. And there are 20 different ways you can get 3 dice, none of them being the same. And so the probability of that will equal to 120 over 216. So as you can see here, chance of getting all 3 dice the same will equal to 6 over 216. The chances of getting a pair will equal to 90 out of 216, and the chances of getting all 3 dice different will equal to 120 out of 216. Now we can compare the probability of getting each values on 2 dice with these possible chance of getting each of the combination. The chance of rolling 3 dice and then getting all the 3 numbers the same is equal to the probability of rolling 2 dice and then getting a 2. So we will just say that if we roll 3 dice and all the 3 numbers matches, we'll just say that's a 2 when you roll 2 dice. Now look at the probability of rolling a 3, 4, 5, 6 or 7 with 2 dice. If you add them all up, you'll get a probability of 120 over 216, which is the same probability as getting all 3 dice different when you're rolling 3 dice. So that means out of the 20 combinations of when you're rolling 3 dice and all 3 dice is different, if you can categorize that 20 combinations and assign it to each of the values from 3 to 7 in the probability that is the same as when you're rolling 2 dice, then you have it. And then similarly for the numbers left, 8 to 12, 8, 9, 10, 11, 12, the probability of getting those numbers when you're rolling 2 dice will be the same as trying to get a pair when you're rolling 3 dice, 90 out of 216. So again, if you can assign all the combinations of the pairs to match each of the probability of getting 8 to 12 with 2 dice, then we also have it. The next stage is just purely trial and error and just trying different methods, different combinations of just random stuff and trying to get something that works out, that fits to our criteria and what we're trying to get. First thing I did was dealing with the 30 pairs first. So out of the 30 possible pairs, I have to distribute that along each of the numbers 8, 9, 10, 11 and 12 in their probabilities according to when you're rolling 2 dice. And so what I found that I had to do was I have to distribute 10 of these combinations of pairs so that it gives out the value of 8 with 2 dice, and then 8 of these combinations to 9, 6 of them to 10, 4 of them to 11, and 2 of them to 12. So that's say you try and work out the probability of getting an 8 when you're rolling 3 dice. There will be 10 different combinations of pairs that you will get, and then each combination of pair will have a probability of 3 over 216. 10 times 3 over 216 will equal to 30 over 216, which equals to the probability that you will get when you're rolling 2 dice and then trying to get an 8. And that argument goes the same for each of the numbers from 8 to 12. And so the method I found of doing this was to take the number, the single number, whatever that single dice that's not paired is, and then subtract that by the value of the pair. So if it's 1, 1, 2, you would take the 2 and then you would subtract it by the 1. Now it doesn't really matter which order you subtract it by, because then you will put a modulus function around it, so you only get positive numbers. This might sound a bit random why I would do this, but if I were to list out all the combinations that I could get with a pair and then show you which number it would give out when I go through this process, and you can kind of see a little pattern. Now to finish it off, you just add 7 to that modulus. Whatever you get out of the modulus, you add 7 to it, so that it just gives you directly to the number that you would have gotten when you're rolling 2 dice. So that's simple enough, but then the next one's a tough one. So now we have to assign each of the 20 combinations that you could get when rolling 3 dice with the numbers 3, 4, 5, 6, and 7, so that, again, their probability is going to be the same as if you just roll 2 dice. And what I found is that I have to assign 2 of the combinations of when I'm rolling 3 dice, 2 of the combinations of getting no pairs to the result 3, and then I have to assign 3 of the combinations to result 4, 4 of the combinations to result 5, 5 of the combinations to result of 6, and then 6 combinations to result 7. This was for the same argument as before. Now this really came out randomly, and I cannot explain why it works. It doesn't work that well. I'll tell you a fault in it, but it does work well enough that I'll make a video on it. So what you do is, when you're rolling the 3 dice and then you get 3 numbers, you take the 2 lowest number, you multiply them together, then you multiply it by 2, then you do 43 minus that certain number, you mod 5, and then you plus 3. And they'll turn out you will spit out a number between 3 and 7. And then whatever number that is, that's the value that you're getting. Now this sounds a bit too good to be true. And it is. Because there is one little catch that I cannot get around no matter how hard I try. There's something. Because the chances of getting the numbers 3, 4 and 7 is perfectly alright. But the chances of getting numbers 5 and 6 somehow are mixed up. Because here the chance of getting number 6 is supposed to be the chance of you getting number 5 and vice versa. So what you do is you just have to remember, if you get number 6, that actually means a 5 when you're rolling 2 dice. And if you get a 5, it just means you're getting a 6. There is no workarounds that I can think of. I'm very, very sorry, Matt. I'm very, very sorry. So this video was a mess. But here's a summary of my solution to the problem, which is also quite a mess. So say you roll 3 dice. First you see whether you've got 3 of a kind, 2 of a kind, or you got nothing. No pairs, no whatever. Now if you get a 3 of a kind, you get a triple, that's automatically going to be the value of 2. If you get a pair, then you will subtract the pair value, the value of the pair, by the value of the other dice. And then you just find the absolute value of that, and then plus 7, and that will be the value you get out of the 3 dice. But if all the 3 dice are different, then you multiply the 2 lowest dice together, times that by 2, and then do 43, subtract that number, mod 5 of that number, and then plus 3. And whatever answer you get, that's going to be your value. Unless you get a 5 or a 6, then if you get a 5, then your value is actually 6. And if you get a 6, your value is actually 5. So now for those people who are still confused, including myself, I'll attempt to do this with 3 dice, and I'll tell you what value I get out of it. So let's roll 3 dice. Right, so I get a pair, a 4, 4 and a 6. So what I'll do is I'll do 6 minus the 4. Or 4 minus the 6, whatever. As long as you find the absolute value of it. So 6 minus 4, that's 2. 2 plus the 7, that's a 9. So this combination of dice will be equivalent to a 9. Now let's try another one. 6, 6, 6. This is pure luck, pure random, but this, because it's 3 dice the same, this will be the same as a 2. We don't have to do any maths. Now say I roll the die, boom, I got 2, 4, 6, right? They're all different, so we have to use that dirty equation. So multiply two least numbers, 2 and 4. 2 times 4 is 8. 8 times 2 again is 16. 43 minus 16, hold on, is going to be 27, I think, if I'm not mistaken. 27 mod 5 is going to be 2. 2 plus 3 is 5. And so our answer is not actually 5, because if you remembered, if you get a value 5 from the equation, that equals to a 6. So this combination actually is a 6. And yes, I know this solution was a bit messy, but it's alright, you know, it's not supposed to work well. It's kind of just a jiggly kind of random stuff that I do. And thank you very much for watching. This video might be a bit rushed. Someone might come up with a better method, which I don't know if anyone will. But thank you very much for watching, and I'll see you again soon. Goodbye.